Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Harman Kardon hk503. This one is, let's just say, it's amazing it's still working. There's a lot of shenanigans going on with this amplifier, and we're going to fix them up. We're going to fix them all up, but a lot of things. This one came to me, and I was been listening to it for the last 2 or 3 weeks. And for the most part, it sounds good. It sounds okay. Not spectacular like it should. It just sounds okay. And but there's other problems, serious problems. One of the problems is when I turn it on, you get an enormous power surge through your speakers. Now, when this is working properly, you should turn it on. It should be silent for the first 4 seconds, and then the internal muting cuts out and brings the music through. But this is not doing that at all. As soon as you hit the power button, you get a big thump, bang in the speakers. You get what sounds like full rail voltage put on the speakers cones, and it's quite alarming and quite frightening, to tell you the truth. And I got to the point of just shutting off the speakers and then turning it on, and then turning speakers back on, just to avoid that, because I don't know what kind of damage it's doing here. Yeah. And then I'm also looking at, as soon as I got under the light here, I can see a lot of stuff going on that I didn't really notice at first. Got some candle wax here, for one thing. I don't know why there's candle wax on top. But somebody's been happy with the sanding block, and they sanded this bar. They sanded the sides, they're loose, and they sanded them with a sandpaper. It's quite coarse grit too they use, because it is a very rough feeling sand job. And the corners are now rounded. Like, these should be sharp, razor sharp when they come from the factory. They should have sharp corners, but these are all rounded now because somebody got carried away with the sandpaper. They were trying to remove scratches, and looks like they got a little carried away. Overall, it's not bad, I guess. That one's loose. This one's not. And then there's some pitting going on here in the front panel. There's quite a few spots where it's not very good. It looks like corrosion. Or maybe somebody was trying to do something else, but it's quite deep. I don't know if I can repair that. I don't know if they tried sanding the front too. This here might be coated. Sometimes they put a coat of clear lacquer on the... Okay, that's not coated. That's just bare metal. So whatever they was doing there damaged the surface. I don't know if I can restore that without it looking obvious, because we have all our silk screening and stuff, and it might be a difficult one to fix, but I'm going to try. But let's have a listen here. Let's turn it on and we'll see. Silent. Did you hear that scratch noise? It was very faint. Another thing it does is when I shut it off, it does pops and crackles as the capacitors discharge. Now we got a buzz. That's Phono. Tuner auxiliary. I never noticed that before, but there was a hum when the power was turned on. You could hear a hum, and it's quite noticeable, and then after about 20 seconds it subsides and it goes down in volume. But this is something I've never heard before. So let's turn it off. Hear a pop, And there's some noise coming out the left channel right now. Some crackly noise. Let's turn it on again. There we had the right channel's acting up now. So this thing's messed up. Oh, more noise. I was kind of hoping it would just blow itself up, but it won't. Can you hear that when I turn the power off? As the capacitors discharge, there's crackly snap noises. Yeah, so we got some work ahead of us. Yeah, it's very noisy, I know. And it's, like I said, it's quite frightening when I have it connected to my nice speakers and you turn that power on, you're getting 40 volts or whatever on the speaker, and it gives quite a bang. But let's see, there's some shenanigans going on inside too. So let's have a look. Alright, screws are out. Cover comes off. Some nasty corrosion here. That's gross. This side. We got some corrosion here, and so this has me concerned. Why it would have corrosion like that on the inside. And here we are. Now, I don't know if you notice anything. First thing that jumps out at me is somebody put caps in this thing, and they didn't use the best quality caps. There's a Chinese brand here, 50 volt, 4700 microfarad. These were replaced. These ones too. All of these caps have been replaced. Now, I don't know if you're staring at it right now, but this thing should have the batwing transistors. Somebody took the batwing transistors out and replaced them with these Sanken transistors. Not a problem, but there is a problem. If you look at these, let's have a look here. What do we got? We got a 2SD2389 and a 2SB1559. Now if you look up the data sheets for these transistors, they're not transistors, they're Darlington transistors. So somebody took out the batwing bipolar transistors and put in these Darlingtons. And from what I can tell, everything here looks untouched. You can use Darlington transistors, but you have to remove the driver and reconfigure the circuit so that it works. But I don't think they did that. So they used these Darlingtons in place of bipolar junction transistors, and that's really a bad. It worked. You know what? It worked, and for the most part it sounds okay, but it's just not right. Let me pull the bottom off and have a look. Alrighty, screws are out. Yeah, somebody's been working on this. These caps haven't been changed. These are originals. TK caps. So it's seen a partial recap. What's this? Smoke? Something blew up here. You can see this big black mark. It's soot. Yeah, it's definitely soot. So something blew up here. This capacitor is all black. This is black. Looks like somebody replaced maybe some parts here. I don't know. This looks like a little regulated power supply, probably for maybe for the phono stage. I'm not sure. but I had some carnage going on here. Another thing I noticed is when it's in use, let me turn the power on here and watch the meter. Ooh. Yeah, it jumped up to the several hundred watts. And then it idles around 19 watts, which is low for this. It should actually be closer to about 30-35 watts if the bias is set up properly. I don't think the bias is set up properly, and we can check it right now. I'll get a meter and we can see if we have bias on. Where are we here? Let me see if I can find the emitter resistors. I know they're hidden somewhere. And I'm going to go across both emitter resistors on this side. What are we getting? We're getting nothing. And let's do the other side. Nothing. So the bias is turned right down. That's why it's they got no. We definitely have some mess to clean up. Somebody else's mess. So here's a look at the DC offset. Left channel. This thing's turned on, right? Speakers are shut off. Left channel. About 6 millivolts. 7. Right channel. 20 millivolts. So that's okay. That's within spec, but we have absolutely no biasing on our output devices. Plus, we have the wrong output devices installed. And the more I look at this, the more I'm seeing. So yeah, this is going to be a complete overhaul. Funny thing is it's working, and it kind of worked okay. Like it sounded okay. Like it wasn't really. With zero bias, you're going to have crossover distortion, and you're going to have. It's not going to sound as good as it could, but it did work, and it did sound. You know, the channels were balanced from each other, and whatnot. But most alarming thing is the power on, power off. So turn this off and listen for the crackling. That's the left channel. It makes a lot of noise. Turn it on, you get the bang. Yeah. So that tells me either a cracked solder joint or a bad transistor. And I'm beginning to think it's a bad transistor, because let's tap on the board and see if we can recreate any cracky poppy noises by tapping on the board. So let's flip this over again. Actually, we'll just do it from above here. Ooh. That didn't sound good. But, you know, I think those transistors they installed, they just won't blow up. Let's try this, see if we can get provoke any noises. Because if you have a cracked solder, doing this will make it identify itself. And everything here sounds good. There's nothing going on. Do the other channel. So yeah, it's looking like we got bad transistors in both channels. I don't see or hear any problem with cracked solders. So we can pretty much rule that one out and assume it's a bad transistor or two. Oh boy, where to start? I don't know why we have such a severe hum on our input. I wonder if we have a bad ground. Okay. Tape monitor 1. So that tells me a lot right there. That noise is coming from before the tape monitor switch, because the switch is able to cut it out. Left and right, yeah, it follows the tone controls and the treble controls affect it. So wherever that noise is coming from, it's coming from very early in the amplifier, right at the input. Okay, that tells me a lot. Alright, so what do I do? Where do I start? I'm thinking first I want to work on figuring out the power on and power off noises, like the big crackly pops. I think we have a bad transistor somewhere here. So I'm going to start yanking transistors, and we're going to put them on the curve tracer. We're going to see if we can find which transistor is offending. I have a feeling we got more than one because we got both channels affected. Got to do something about these transistors. This is not right. We got to yank these transistors out and put some proper ones in. And these caps too. I think these caps are low quality caps. We'll have to see how they measure up. And a lot of other caps were not replaced. So some of the caps were replaced, not all of them, because they're still on the tone boards and stuff. There's still original caps. And then we need to figure out the hum noise, which I think might be coming from back here. Someplace before the tape monitor switch. So we got a lot to do here. Let me get started. So look what I'm finding here. This is screws are missing. There's 2 screws missing from this side. 2 screws missing from this side as well. So yeah, there's going to be lots of interesting stuff going on with this amp. Start to see the nastiness going on inside here. This is all smoke damage. There's quite a big stain here from something. A lot of smoke damage. It's filthy. The front is filthy too. And the recesses for the knobs, they're just packed with grunge. So this is really nasty. Somebody cleaned it up to make it look good, but it's still got a lot of nastiness going on here. So for the most part, all the switches and pots on this are working well and they're behaving. Not really. I didn't really encounter any problems with switches or pots, like channel cutting out or scratchiness. Everything worked good. I think somebody hosed them down in its previous life, but there's still a lot of, this thing's got a lot of issues. I didn't realize it was this messed up when I was using it, and like I said, I used it for about 3 weeks and I enjoyed listening to it. It had a nice balanced sound between left and right. You know, everything sounded okay, but it just wasn't really singing like it should. And now that I realize that there was no bias on those output transistors, and there was no no bias with that. There's no all that crossover distortion would be there. So I'm just going to take everything. I'm just going to remove the whole front panel because I have to go in and redo, well, not redo, but all the caps that weren't replaced before I'm going to replace. So that when this thing comes out, it's going to be fully recapped, not just partial like it was. So still lots to do here. A lot of cleaning, a lot of grunge underneath here. I didn't notice that the grunge was so bad. And probably what I'll do is I'll end up cleaning switches and pots too, just to make sure everything is 100% before it leaves here. Now that I'm getting into it, I'm starting to smell some odd stuff like pets and smoke, cigarette smoke, and a few other things I'm not pleased about. But we'll have to clean everything. I should really be wearing gloves, but oh well, live dangerously. Just about done here. I got one headphone jack to remove. Oh yeah, everything's got that green Loctite. Wants to spin. Can't really hold it. I wonder if I hold it like this. Come on. Okay. Tell this was not a part before. Okay. What's holding? Oh, this thing. Push it in. There we go. Lots of filth on that. Doesn't really show on the camera, but it's all smoke stained and dark. But we are in, and we can now do a service for all of our circuits. We can do that. We can access all this now in our tone board. So we'll get started on that, and I'm going to service these switches as well. Even though they sound good, I'm going to check contact resistance on them and make sure they're 100%. Somebody even sprayed the power switch here. Okay, so let me get started. So I'm getting started, ready to do the recapping here, and I started on the tone board, so I assembled my caps and get them ready. And I pulled out the first two, and these are 330 microfarad by 16 volts. These are Mashishita caps. I'm surprised they didn't leak all over the board, because these are notorious for leaking. But if I look on the, I don't know if you can't see it here, I'll zoom in. If you look on the board where they were residing, it looks like they were leaking, and looks like the electrolyte was coming out and staining the board. You got some crusty there, but we're going to replace these two. C28, this is C27, C28. These are power filters. I pull the first two out and I decide to check them, and this is what I get. And I'll show you here. And this is probably going to be typical of all of this amplifier. So have a look at this. So that's a 330 microfarad, and it's reading 50, and it has a 2.5 ohm ESR, which means that capacitor is junk. It is now scrap metal. Here's the next one that I pulled out, and this one's even worse. It's reading 38 microfarad, 2.4 ohms ESR. And this is what I'm going to replace it with. This is a 470 solid polymer, and this is what we get. 463 microfarads, 77 millivolts ESR. So these replacement caps will do nicely in this application. But I expect a lot of these caps here will be the same kind of condition. These ones are Mashishitas too, all these blue ones. And I'm going to replace these tantalums. I'm going to yank these tantalums out and replace these with electrolytics as well. There's 8 of them here on the board. This board up here is, I believe this is the Phono stage up here. And this has TK caps, blue TK caps. I expect these ones will be dead too. These TK caps are even worse than the Mashishitas. Anytime you get electrolyte leaking out of a capacitor, you gotta go in with a cotton swab and some alcohol and clean off the old electrolyte because it's corrosive. Now you can't clean out what gets down into the hole, but you can clean off what's in the surface, and hopefully it stands a better chance of surviving. I don't know why he's got these 3 pins here. I'm also seeing some candle wax here. If you can see that sprayed all over the board, that's not going to do anything. It's not. I'll just scrape that off. I don't know why there's candle wax there. Okay, what are we looking at here? This is the tone. No, this is not the tone board. This is the Phono equalization board, and it has on it a power supply. If I can roll this up so you don't break anything. Right here, there's a positive negative 15 volts power supply. There's a couple transistors here with heat sinks on them, and a couple Zener diodes. And this was populated with 4 capacitors. A couple of 100 microfarad and a couple of 10 microfarad. And all the capacitors were baked, and they read, in value, they read picofarads and mega ohms of ESR. So they are all open. And so what I'm going to do, just to prevent the new capacitors from getting baked, is I'm going to replace the caps on the back side of the board, and we'll put these ones here as well, like this. But I'm also getting cracks here on these joints. Now these joints look like they are on the transistors. I didn't confirm that, but I don't know if you can see these cracks. Let me zoom in if you can see those cracks. I don't know if you can see this one here. It's I can flow this one right now. See how that, when you put the heat, oops, way too much. When you put the heat on it, it opened up. That one was okay. And this one here is cracked as well. It's going to reflow these joints. So I think I got that, and then these are going to get mounted here, so I can solder these in place. Okay, there goes one. I have to make sure I orientate these right. Now the reason I'm putting them on the back side is to keep them cool. These solid polymer caps, these are for power supply use. I always use solid polymers now for power supply filtering. And because they have superior ESR and they retain their value better. So these won't get cooked in the future. They shouldn't anyway, because they're on the opposite side. All the heat should be contained on the bottom. Let me see if I can get this unsoldered. Okay. Now, that power supply should be trouble-free for a lot of years. This power supply supplied power to the tone board, and that could have been our source of our pop, sizzle, crack. I'm not sure, but we did have cracked solders on some of these transistors, so it's a good chance it was. And we had open capacitors, which would also maybe explain our 60 hertz buzz and hum we heard. I don't think so though. So this board's done, and we can get this back together. The tone board has been done. See it under there, it's all nice and finished. And that concludes everything in front here, with the exception of the switches and pots. I'm not going to touch the pots. They had no problems, and even the switches are good. So I might leave the switches alone. I might test some of these contact resistance. If I get really bad ones, I might yank it out and clean it. But for the most part, this is all done. Now, capacitors on this board, 100% of them failed, with the exception of the tantalums. The tantalums were still holding up, but they were kind of drifting with ESR and value as well. They were starting to fail. On this board, I think I had 2 capacitors that were still okay. The rest were completely failed. So I replaced all those, and the 2 tantalums on this one were failing, so I replaced them as well. It's got a gain of 247. That can't be right. It's a Darlington. Unless that's normal gain for a... Oh, let me try. Yeah, let me try another one here. Let's try a NPN one. $163. Interesting. I read the data sheet on these transistors. I think the gain should be higher than what's being displayed here. But they're coming out and they're not going back in. So I'm just going to remove the heatsink because it's in the way of everything I want to do. Let's just get this out. Okay. Can clean this all up and then I can work on this properly. I remove these caps. These caps are 4700 at 50 volts. You can see what brand they are. This Samwa brand. They're Chinese. They measure okay. They're okay caps. They got low ESR, like 20 milliohms. But I got a better solution than this. I'm going to take these out and upsize these to better ones. And I can now work on this without any impedance. This big chunk of metal in the middle. So I can get in here, and some of these caps have been replaced with Chinese brands. I'm going to pull them and test them and see if they're okay. I assume they are. And then these 2 Darlington transistors here are the bias transistors. These usually drift in HFE, so I'm going to pull these as well and test them. And then I'm going to test the drivers and pre-drivers and everything. I'm going to make sure that everything's 100% with this thing before I button it back up. I want to find the cause of that snap, crackle, pop. I think we have a bad transistor here, but it's hard to say. It affected both channels. More the left channel than the right, which tells me it's not power supply. It could be power supply, but if you have power supply problems, it's going to affect both channels equally, or at least it should. But this was more on the left, but the right was acting up too, so we might have ditzy transistors somewhere in here. This thing is just loaded with surprises. So here's a capacitor that was replaced, and it's a 3.3 microfarad 50 volt C8. Now this capacitor in the service manual should be a 33 microfarad, not a 3.3. So somebody made a mistake, put a 3.3 in there instead. This little circuit here controls the time constant for the turn-on delay. So when you turn on the amplifier, this cap takes X amount of time to charge up, and then once it charges up, it turns the power on for the amplifiers. It makes them wake up. It's about 4 seconds. But with this cap in here, it's probably half a second, I'm guessing. I don't know. Yeah, so this thing is just never ceases to amaze me. Now I looked at the data sheet for these 2 puppies, and these are ranked Y. You see the Y on there. They should have an HFE of between 15 and 30,000, but they didn't measure that. They measured down around 100 or 200. So I don't know what's up with that. I don't know if these are defective or if maybe my little meter doesn't read them. But these also here, these, where's the other one? I pulled them both out. Okay, so these two transistors, these are two SC1472s. I don't know if you can read that. These are Darlingtons as well. Let me turn the lights off and let's measure these to see what they should be around 1500 or better. And if I can't remember what the data sheet says, but I think it's something like 2400. So let's see what this one measures. Oh, this one's at 14,000. Okay. What about this one? This one's at 12,000. Okay, so these two transistors are fine. I'm going to put these back in and run with them. They are good. Fuse roulette. Let's see what we got here. It's supposed to be 6.25. And what do we have? 7 amps. Not correct. Oh, that one was loose. Come on. What's this one? 7 amps. Okay, that's a fail on both. So we got some new 6.3s or 6.25s. And we're going to squeeze these back together because they are way too loose. Pop a new fuse in. Okay, I want to bring your attention to these two resistors. This one here and this one here. They're 22 ohms, 5 watts. And the connections on the board are cooked. You can see here how it's cooked. The pads are lifted and disconnected from the board and it's been overheated. Same down here. Well, you can't see. Same down here. Now what that is that's your Zobel network. Now there should not be any current going through and cooking these resistors because there is from the speaker output it goes to the resistor and then it goes to a capacitor. I believe the capacitor is 100 nanofarad. Yep, 100 nanofarad capacitor to ground. So no DC current should flow through this, okay, and no AC current below a certain threshold should flow through this, like any low frequencies. You start getting up into the multiple kilohertz range, then you start getting current flow here. But the way this is burnt like this, it's seen heavy energy, like a lot of energy going through it, and both channels too. So I'm wondering what caused this, because that shouldn't happen unless you have, let's say, a high frequency oscillation in your amplifier and all your energy is going out the back here through and the Zobel network is dumping it to ground. That's why we have heat here. So we shouldn't have heat. So I question what's going on with this, why this happened in the past. Something happened. Like I said, either it was a high frequency oscillation or it was a signal that was fed in that the Zobel network just overloaded. Alright, so I'm going to fix this up. Really nothing you can do with it. The pads are loose on the board and I might just glue them back down somehow. But we can bypass this and put it somehow. Another thing is, if these capacitors fail and they go short circuit, then you have a 22 ohm resistance to ground, and then you could get a lot of energy going through this resistor if you're playing loud music. But I'll check these caps. I kind of highly doubt they'll fail. I've never seen one fail, those green Mylar caps. So we'll do that. Also went through and pulled out all these transistors and checked them, and they all test good. I put them on the curve tracer, and they're all stable and predictable and They all fell within their HFE range. So I'm going to leave them all in. Really not much I can do to the amplifier. Some of these caps are cooked though. You can see they're not green anymore, they turn black. I might replace a couple of them. Now if you watched the hk503 receiver video I did a few episodes back, I made some mods to the grounding scheme. And I'm going to do the same mods to this one because this one is still a mess. Like we have a ground from here, jumps over to here. And then we have two ground wires coming off of here, going to here. I don't know why. And then, let's see, this grounding scheme is different. They don't have the loops that go around from back to front. But here's our ground zero right here. This is the center tap of the transformer. And then from here it splits off up to this cap bank and down to this cap bank. So I'm going to redo the grounds scheme on this. I'm going to split the grounds for left and right and tie the grounds to the left and right power supply like I did in the 450 video. And that should take care of a lot of stuff that's going on back here. This ground wire comes up and it goes, okay. I see what they're doing. They got a wire here, comes down and then goes into this tube and goes up here. Same with this one, it comes up from here, it goes into this tube in there. And so we got 4 wires going in there. I can see 4 now. We're going to clean this all up. We're going to make it better. And we can upsize the wiring too while we're at it, like we did in the last one. I think that made a little bit of improvement. And then finally, we'll have to get some power transistors for fitting. So it looks like I was right. This cap is shorted. Got my tester here. It's a 100 nanofarad cap, 50 volt. Completely cooked and shorted. I'm going to replace them both. I'm going to replace a lot of these caps because they're not green anymore, they're black. I don't know why that saw so much heat. There's no reason for that heat on that cap in the back corner of the amplifier where there's no other reason for getting hot. I'm going to replace these Samwa caps with these Cornell WAs 6800. Same diameter, a little taller, more capacitance, better quality. Alrighty, so I've been doing lots of work off camera here. I haven't shown any of it, but we got all full recap. The original tech that did work to this only replaced 8 caps, and 4 of them were the power capacitors. So there was a few other, and even he got one of them wrong. So we replaced all those, and we have all new caps, which was a good thing because I don't think I've ever seen a receiver or amplifier with such bad condition in parts. But we're done all that, and I reconfigured the ground scheme on this thing. If you saw the hk503 video, go back and watch that. I did the exact same thing. I isolated the left and right grounds, tied them back to the power supplies, ran a 12 gauge wire here to connect these 2 grounds, and got rid of all those wires that there was 4 wires going back. Got rid of all that. Tested all the transistors in the amplifier. I still did not find the cause of the power on bang and thump. Now I'm at the crossroads here what to do with picking power transistors. I think I have a good selection here. This is the MJE 15028-029. These are complementary pair of transistors. These are TO220. And I think I'm just going to reuse the holes that somebody drilled in here. They drilled and tapped holes for the power transistors. Instead of putting bat wings in, I'll just use the hole and I'll put a TO220 transistor. Now, we're not going to have the same power dissipation as the original bat wings. I think these are 50 watt transistors, if I remember correctly on the data sheet. Now I can upsize these to TO3P size cases like the original tech did. I really don't like that solution though. But if I do that, I have a whole range of transistors that I can select from. different different parts I can put in. But I think this will be good. I think these will be good for this. We'll try it out. If we, we're going to be doing power testing and everything. If it blows up, it blows up. We'll figure out something better. But for right now, I think it's good. So, time to put the transistors in and put the bias transistors back in. I haven't done that yet. And I've just been doing some reassembly here, putting the front subframe back on and connecting everything and cleaning boards. This thing needed a lot of help, and it was pretty poor shape. I was surprised that it even ran when I listened to it for the last 3 weeks. These pads are pretty much destroyed from the previous tech. I have to reconstruct. Well, I'm not going to reconstruct, but I'm going to have to figure out a way to make sure that we have a solid connection on all these transistors here, because their pads are all torn up. I think I need to address this power switch. I think this has been monkeyed with. This here is just about broken. It's very weak now, and it's just hanging on by one strand. Not anymore. And it was kind of blob soldered on. That's not factory for sure. I don't know what happened there. I don't know if somebody replaced this power switch. That's possible they replaced it. It looks legit. It's an ALP switch. And everything's good that way. The wires are original, because if I go over here and look, you can't see, it's very dark. You got the original wires coming here, and they are the factory heat shrinking, so that's all good. So nothing's changed here, but something's changed here. So I'm going to resolder all these connections and insulate them properly. And maybe this capacitor is really not rated for the task. It's 10 nanofarad CSA approved cap. This cap is measuring down about 25% in value, so I'm just going to replace it. It's ceramic disc. It shouldn't change value with age. I don't know. Maybe it suffered some trauma. Alright, we're all back together. I think I'm ready to do my first power up test. So let's apply line voltage and see if it blows up. No, it's behaving exactly as it should. Ooh, that went into over bias. Did you hear the transformer struggling? So something's going on with one of my adjustments. I need to figure out which is the bias adjustments here. I think I did treat these pots, so let's try turning these down. You still might have a problem. My speakers are turned off, everything's off. Maybe, let's try it one more time. So here we go. Yeah, it's climbing up in power. There's something wrong. I wonder if it's in an oscillation mode. Let me connect the scope and we can see what's going on. Because as soon as it came out of Protect, the power started ramping up, and it was not too good. It was pretty scary. Alright, so let's do another test here. I have got 8 ohm load connected, and then we're scoping off the load. And should be able to see it. Let's turn this on, and we'll see what kind of transients we get. Got nothing. Yeah, the bias is running away on this thing. We still have a problem. It's not an oscillation, and it's not, heavy offset, DC offset. It is something. Let me try it one more time. I just want to watch this watt meter. get ready to shut it off. See, it comes on, it just ramps right up. Yeah, it's not cool. But we can find out which channel's doing that. We can put a voltmeter across the emitter resistors, and we can see which channel's hogging the current. I'm pretty sure it's probably not both of them. It's probably just one of them. So let's do that test one more time. Let's get a voltmeter across the emitter resistors, and this will tell us right away what is going on, because all that power is going through somewhere, and it has to be through the output devices. So we'll just go across here, and I hope my meter can respond fast enough. I might have to get an analog meter. Let me try this here. You know what? I'm going to get switch meters. Alright. So I got a voltmeter between the two emitters. Let's get a good angle on this so you can see it. There we go. And then the watt meter, turn it on. I got a 1/4 of a volt already. That's not cool. 1/2 a volt. I got to open the emitter resistor. Is that what the problem is? Or did I connect it up wrong? Give me a second here. Okay, I got probes on across both emitter resistors for the voltmeter in the back here, and this is for the rate channel. And here's the watt meter. I don't know if you can see this. When I turn it on, watch what happens. You get 0, 0, 0 until the amps come alive, and then we get heavy conduction, like 1/2 a volt across, which is essentially 0.44 ohms. So there's a lot of current being dumped through there, and the transistor is being turned on heavy. So something's going on in the right channel. The left channel, I did the same test and it came back clean. I only had about 9 millivolts of drop across both resistors. So this channel's healthy, the left, but the right has got problems. So let me try and figure out what's going on here. Something is wrong with the biasing circuit on the right channel for sure. Now, it could be something simple like maybe a bridge solder joint that I overlooked. But I did have all these transistors out and tested them. They were all fine. Alright, here's a look at the power on circuit. This transistor here controls the turn on delay of these amplifiers. So it picks off through D13. It picks off an AC signal off the transformer, and it rectifies it to a negative voltage, which is B5. And voltage at B5 is, well, it really doesn't matter. Let's see here what B5 is. Yeah, B5 is negative 8.5 volts. Okay, let's go back down. So what's going on here, what's going on here is that this capacitor C9, this takes time to charge up, and once it hits a certain point, this transistor turns on and it grounds. This is ground here, and it grounds through these two diodes, this point and this point. It causes these two transistors to turn on, and current can flow through the long tail pair, and that's our power on delay. So when I first turn the amplifier on, everything's kosher until this transistor turns on, and then from there things all hell breaks loose. Now, the amplifier is nice and stable when it's shut off, right? When this is off, everything's nice and stable here. But as soon as we start getting a signal through Q407 and turning this amplifier on, it all hell breaks loose. We have over an amp flowing through these two transistors, our output pair. I think I measured 1.1 amp before I shut it off. But I checked all this. This is all fine. Everything in here is fine, and I'm beginning to suspect D407. It's a MV12Y, and I measured this diode out of circuit, and it measures 3 diode drops, so it's about 1.5 volts. I'm wondering if this diode's gone bad. An easy check would be to take the diode from the other channel and swap it and just see, because as far as I can tell, everything else is working. All the transistors are working as they're intended. I pulled them out, checked their HFE, checked them on the curve tracer. They're all fine, except these 2 diodes. For whatever reason, the bias is being turned on too hard. Q415 and 416. These are the these are the Darlington transistors that's mounted on the heatsink. Over 1 amp going through these output transistors. 1.1 amp I think I measured across, measuring across these resistors. I measured almost a half a volt over 0.44 ohms. If you do the Ohm's law, that's 1.1 amps or something close to that. And if you figure that this is plus 40 here and negative 40 here, we have an 80 volt potential. So if you figure 1 amp at 80 volts, you're getting 80 watts of dissipation on those 2 devices when this thing comes alive. So that's an incredible amount of power it's dumping through these resistors and transistors. And it won't last long, so that's why I only turn the power on for a few seconds, and then once it starts ramping up, I shut it off, because these will easily overheat. They're going to be operated outside of their safe operating area. So we have limited time to do our testing. So what are we looking for here? So we've pulled out actually these 6 transistors, actually 7 transistors here. These 2 are new. These 7 transistors here were pulled out and tested, and they all tested fine. But obviously something's wrong, and this is one of those, well, typically you're going to have transistors, when they fail in either hard short or open. And that's 95% of your cases. You're going to find dead transistors as shorted junctions or open junctions. But you're going to get that 5 or 10% where they just misbehave and they're doing really weird stuff. And I think that's what we have here in this case. We have a transistor that's misbehaving. We could have leakage through one of these transistors, and that could be setting this bias circuit up for failure, which means if we have leakage on one of these transistors here or here, we could have excessive current going through this tree, and it could upset the apple cart, so to speak, and cause the bias to go wild. So how do we do this? Now, if you're really stuck, what you could do, it's very time consuming and it takes a lot of labor, is you can swap parts from one channel to the other and see if the problem goes with the part or if it stays with the channel that you're working on. For example, if you suspect this part, you could pull this part and replace it with this part. They're identical in parts. They should be identical in part numbers. You can check that when you do that, and you'll know right away if you have that problem isolated or not. But that's kind of, it's not really a good way to do it, because you're wasting a lot of time. We want to get smarter about this. Another thing you could do is you could just shotgun this, and you could just say, okay, well, I'm going to replace all these transistors, so let's replace 6 of these transistors, and that'll cure the problem. It probably will, and that might not be a bad solution, but it also might not fix anything. You might change these 5 or 6 parts, and then you find out you still have the problem. Now what? Well, what Harman Kardon's done is they've made it easy for us. Is they've given us a chart, and this voltage chart has measurements for each transistor and what the voltage should be under normal operating conditions. So for example, all these transistors here, they're on the collector, they're plus minus 40. That's because these transistors are connected directly to the rails, right? And then you have your base and your emitter voltages. So what I'm going to do is I'm going to go through and do some measurements, on all these transistors. I'm going to do all the odd number ones in the 400 series. So everything from here up to here I'm going to measure. And we're going to measure these, and we're going to see what values they are. And we're going to see how correct it is to the chart. Now, if we have an outlier here somewhere, we're going to know that we're zeroing in on the part. So let's say, for example, Q413 doesn't measure 1.8 volts, it measures 3 volts. So Q413, 413 collectors 3 volts. That means this is too high, and we can figure that out from there. So I'm going to turn the camera off, I'm going to do some measurements, and we'll see what we got. Okay, so it's the next day. I'm going to make an executive decision here. I'm done with this thing. I spent the whole day yesterday chasing all these voltages, trying to measure them and stuff, and I noticed that something was going on. Some of these voltages were changing, and they weren't consistent. So I have a feeling I have intermittent problems within these transistors. And like I said, I spent the whole day, I got nothing accomplished on this, made no progress. So what I'm going to do is I'm going to shotgun this. I'm going to replace 6 transistors. The 2 drivers, these ones are already new. The 2 drivers and these 4 here. And I have some substitutes in mind that should work. And I'm going to do that. I'm going to see how this, because there's no reason. And another thing I noticed is I was working on one channel, and then the other channel started doing the same thing with the excessive current draw. Why is it doing that? Both channels, I don't know. But we're going to figure this out. Okay, I feel like a fool, but I'm going to tell you about this anyways. I figured out what's going on here. I figured out what was wrong. Previous tech put Darlington transistors in for the output devices. Okay, we know that. But to compensate for that, previous tech added another diode in series with the already available varistor. Now that's why I thought it was odd that I measured 3 diode drops here on this assembly. But if you look at the diagram, they only show 2 diode drops, correct? So that's what screwed me up. The person put an extra diode drop here. Now I took out the Darlingtons and I put in regular transistors, so that was now a problem. So let's open this up. I'll pretty much guarantee you there's an extra diode in here that doesn't belong. Let's see if we can cut this open. And that would explain all the hassles I've been having with regards to, oh, here it is right here. Here's a diode. And it was all covered over with heat shrink. Here it is, yeah, a glass diode. So I guess you can use Darlingtons as long as you modify the biasing circuit. But the biasing circuit wasn't working. There was no bias. See, there's our diode. So I'm going to remove the extra diode. We're going to go with the original varistor diode, the double diode. And I am going to continue replacing these drivers. I already got 3 of them in. You can see them here. Here's 1, 2, and 3. I got those installed. And that'll be an upgrade actually. These here. These are most stout transistors, got better cooling. So that'll be an improvement for this. So I'll get this sorted and then I'll bring you back. Okay, I'm back. So I removed those 2 diodes that the previous tech put in. And I double checked all of my transistors just to make sure you have them installed correctly. It's always a good practice to get into, is double checking your work. Yeah, I can't tell you how many times I've installed a transistor backwards and then you flip the power switch and bang, destroys a circuit, and then you ended up backtracking and finding parts and replacing stuff and licking your wounds. But anyways, that's enough of that. But yeah, I think we're all done. I went through and did a cleaning the board, and I gave a good inspection of all the solder joints, made sure there's no bridges. So here we go. We got our watt meter. Let's turn this thing on and fry or fly. There's okay, come out of protection. Went up to 18 watts. Everything's normal. So what we do now is we set the bias and we set the DC offset, and then we're ready to do our tests. Alright, so we're powered up. I'm just letting this warm up for a few minutes. Got my voltmeter here. We're going to do bias. Now the spec from Harman Kardon is 33 millivolts across both emitter resistors. So if I can reach in here, if I can see something, the camera is right in the way. If I can put my probe there, and my other one here. Okay, we're only at 4 millivolts. So we need to turn it up. Let me try this. Do that instead. Now, if we have troubles adjusting bias, then we have other problems to address. Well, it looks like it's going to reach 33. I'm going to turn it up to about 30 because this is going to warm up and it's going to change. So I'll leave it at 30 for now and get the other channel. And then we'll let it stabilize for a few minutes. Okay, here's DC offset. It was up around 1/4 volt. Okay, I'll leave it there. Other channel. Wrong way. Hang on a second here. How far can we go? Right about here, I guess. Alright, that might drift, and I can go back and retouch it up. Now that all the work's been done, this is the last thing I do is I go and I use a little dab of neutral cure silicone and I bond the biasing tracking transistor to the heatsink with a little bit of silicone. That's all it needs just to make a thermal connection. And that'll set up. I should have done that before I did the bias adjustment, but that's fine. So now it's, and if I ever need to remove that transistor, you just cut the silicone and remove it. Now that it's been on a while, you can see the bias drifted up quite a bit. It's up 10 millivolts higher than it needs to be. It's going to tweak it down a bit. This is part of chasing a moving target. When it comes to bias, you want to have your bias set so your amplifier is warmed up and it's stabilized, because during the warm-up cycle this is going to change quite a bit. And I'm also noticing quite a bit of heat on these driver transistors. I think upgrading them to a different transistor was a good idea. What am I reading here? This one's 45. This one's up over 60. 45. Yeah, this one's over 60 as well. So the NPN transistors are getting well over 60 degrees, and the PNPs are staying around 45. So quite a bit of power dissipation on these devices, and that's why I wanted to make sure they had a heat sink. Alright, so ready, wired in to do a power test here. Let's turn this thing on. Everything's set to normal. Okay, on it goes. Turn on our tone source, and we should have speaker 1 connected. Let's turn up the volume. There's our tones. All right. Okay, let me set my poke ropes to ×10. There we go. Here's our clipping. Take it back. Oh, I would say right about here, right there. All right. Now we are putting out 21.2 volts RMS into 8 ohms, and our total consumption is 194 watts. So let this cook for 10 minutes, and then I'll bring you back, depending, unless something blows up. And we're coming up to 10-minute mark here, and we're doing pretty well. Full power. Let's see what we got here. We got a 65 degrees, 66 on this device, which is acceptable. This one's 60, 66, 65. I think these transistors I selected are going to do okay. This is heatsink's getting quite hot, and my load for comparison is up over 120 degrees Celsius. So I think everything is good. Let's reduce power, and let's do some square wave tests. And let's see here. Let's turn this down, and let's turn this down. Let's get some square waves. Uh-oh, we got a problem in the left channel. We got a collapsing signal. Is that something I did? Or is that from cooling down? I'm not sure why I did that, but you all saw it. It was getting twitchy. But let's see how it does on the low end first. This is 1000 hertz tone. (300, 200, 100 hertz). That's 40 hertz, 30, 20, 10. This thing's doing really well. Look at that for 10 hertz square wave. There's no tilt. There's hardly any tilt. Let's see if I go a little lower. 9, 10, or 9, 8, 7, 6. Now you're starting to see a little distortion here at 6 hertz. 5, 4, 3. Now you're getting a lot of tilt. It's actually doing really well. Let's go back up to 1000 hertz. Alright, bass cut, bass boost, treble cut, treble boost, balance control, tape monitor. Here's our loudness and our mono switch. Everything's doing well. Let's go to the high end And let's see how this does at high frequencies. So we've got 5 kilohertz, 6, 7, 8, 9, 10 kilohertz, 11, 12, 13, 14, 15, 16, 20, 20. It's actually doing not bad for 20 kilohertz. And we lose our square wave right around here somewhere, which is 44 kilohertz. Yeah, it's doing really good. That left channel twitchiness kind of has me concerned. So I'm going to run some more full power tests and then bring it down to reduced power and see if I can recreate that twitchiness. I don't know if that was just a dirty switch. I don't think it was, because none of the switches are responding to any movement. You can tell if a bad switch just by wiggling it a bit and your signal drops out, then you know you got a dirty switch. But this is rock solid here. And everything looks good. So I'm going to keep going here and keep poking at this. So here's a look at the parts I pulled out of this thing. So we have these 4 filter caps. These are okay. There's nothing wrong with these. I just didn't like the color of them, I guess. So I pulled them out and replaced them. 4 Darlington transistors, not correct. So I pulled them out, replaced them with regular bipolar junction transistors. Now, I don't know why anybody would do this unless they... yeah, I don't know why anybody would do this and then make an adjustment to the bias circuit with adding diodes. These 4 transistors here were the drivers. For the most part, they test fine, but I wanted to upsize them, so I did, and we replaced those. A couple fuses that were the wrong value, and got rid of that. These are the caps that the previous tech put in. This is the wrong value. This is the correct value, but he put in a 100-volt cap when it was supposed to be a 16-volt cap. I don't know why anybody would do that. It's probably 4 times the size it needs to be. All of these caps are pretty much dead except for the tantalums. The tantalums are all right. The problem with the tantalums is their ESR is all over the place. The value is still kind of correct, but the ESR is just not good. These TK caps, for example, let's see, these ones here are 330 at 25 volt. Let's measure a few of these. If you have the time, hang around and we'll measure some. Let's see here. This one measures 320, 225 milliohms ESR, which is okay. These are probably the only 2 caps in the whole machine that were still okay. This one's 315 microfarad, 235 millivolts, or milliohms. This one here is 100 at 25 volts. TK cap, and it measures 1.48 nanofarads and 184 kilo ohms of ESR. Dead. Its partner in the these are positive. No, this is a different cap altogether. This is a 6.3 volt, 330 microfarad. This one measures 340 microfarad, 370 nanofarad. That's okay. These ones weren't cooked with heat. That one's okay. These 2 Mashishita caps, 330 microfarad at 16 volts. These are the first 2 I pulled out. And if you remember, this one was 49 microfarad, 2.7 ohms. Garbage. This one's 38 microfarad, 2.5 ohms ESR, garbage. And now we get into the smaller ones here, these ones here. These are TK caps, 10 microfarad, 25 volt. And this one measures 60 picofarads. And we have about 10 megohms ESR. That's garbage, completely open. The one in the other side, 146 picofarad, 1 megohm ESR, garbage. And all these blue ones will be the same. They're all dead. Let's pick any old one here. This is a 4.7 at 25 volts. And it measures 3.45 microfarad, 70 ohms ESR. It's dead. Another one, just for example. This is a 22 microfarad at 16 volts. And we got 14 microfarad at 8 ohms ESR. It's dead. So yeah, there are a lot of bad caps in this thing. They were all garbage. And, you know, surprisingly, it ran. This is 100 microfarad, 25 volts. This measures 57 microfarad, 32 ohms ESR. It's dead. So all these little caps. And then we got into these Mylars. These ones I found, this one here was out of tolerance quite a bit. This is a 10 nanofarad, I think. Is it this one or the other one? No, that one reads okay. 9.7 nanofarad, and it's got about a 400 ohm ESR. But the one next to it, in the other channel, well, where did it go? Maybe I'm mistaken here. In these two Mylars, actually there's more than two, there's 4 of them. These 4 Mylars, one of them shorted, completely shorted. And that one, though, is in the Zobel network. And then the rest of them are kind of baked. But yeah, a lot of parts went into it. A lot of bad parts, a lot of cooked parts. And but it's all good now. It's all got brand new capacitors. And it's ready to go. Well, there it is, as far as I'm going to take it today. I want to get this video rendered, edited, rendered, and uploaded for this Friday's release. Because I know I've been slacking on videos lately. I've been doing a lot of other stuff in the background, but this is one of the projects I had going, and it consumed a little more time than I was hoping, especially with that biasing issue. It wrecked a whole day of mine. But it doesn't look too bad. It does, like, I'm still kind of sitting on the fence. This is going to be a good sounding amplifier. I can just tell. Just haven't even listened to it yet, but I know it's going to be very nice. But it takes away from it is these damaged front panel. We've got a damaged knob here. It's got a scratch across it. I think it was resting up against something and vibrated, or I don't know. And then we have, I did clean the knobs in the ultrasonic, but you can see a lot of spotting. I don't know if you can see that. A lot of spotting. It's probably some kind of corrosion. Maybe something got on there that ate away at the aluminum. Problem with aluminum is it's very reactive metal, and it wants to corrode right away when it touches something. But overall it looks pretty good. I don't know, what do you guys think? So yeah, like I said, I want to get this uploaded. Thing about YouTube, I have not been getting notifications from my channel for the last 2 weeks, going on 2 weeks now. So if you guys respond to a video and I don't get a notification that anything's been said, so I don't know what's wrong with. I must be on one of YouTube's watch lists or something. Maybe they think I'm a bad person and they're monitoring me, or who knows with YouTube. You know what YouTube is all about. Nice, cleaned up well. Another thing is I took my email address off the web page because I was getting a lot of spam requests for sponsorships. I'm not interested. Don't bother me with that stuff. But they were really hitting me hard with sponsorship spamming, and so I had to take my email off there for a while. I may put it back after a while, after it cools down, but I'm really not interested in doing sponsorship deals, so leave me alone on that front. Just want to make videos. But yeah, here it is. I'm going to listen to this for about three weeks before I try and pass it off to a new owner. Yeah, that's it for this one. So take care. We'll see you on the next one. Thanks for watching.